If we're solving a first order differential equation which is not separable, we need to check its linearity. A first order differential equation of this form is said to be a linear equation in the dependent variable y. So in here, y is the dependent variable and x is the independent variable. And when g of x, the right-hand side of the differential equation, is equal to 0, we call the linear equation a homogeneous equation. Otherwise, it's non-homogeneous. We can rewrite the differential equation in the standard form by dividing both sides by the lead coefficient of a1 of x. In general, this differential equation has two solutions. yc, which we call it the complementary function or the complementary solution, which is the solution to the associated homogeneous differential equation where f of x or gx is equal to 0, and y of p, which is the particular solution. The first step in solving the first order linear differential equation is to write it in the standard form, and then we can find the integrating factor. After obtaining the integrating factor, we can find the solution to the differential equation. Now let's solve some examples. So in here we have a first order differential equation which is not separable. But as we can see, the first order derivative goes to the power of 1. The zeroth order derivative also goes to the power of 1. And the coefficient of each one is a function of only x. And also the right-hand side is a function of x. So this is a first order linear differential equation. And we need to rewrite it in the standard form. And on the right-hand side here, we can factor out x and rewrite the differential equation, where 1 plus x will cancel each other out. So here we have p of x and also f of x. We can rewrite p of x and find the integrating factor. And then the solution to this differential equation will be equal to y of x we can rewrite the numerator and then integrate it. So in here, minus 2x minus x is minus 3x, and minus 2 minus 1 is minus 3. And for the first 5 terms, e to the power of minus x will be cancelled with e to the power of minus x in the denominator. And in here, for the second term, we can move e to the power of minus x to the numerator. And then we can rewrite the right-hand side. And this is the explicit solution to the given differential equation. Here is the next example. And again, we have the first order differential equation. Again, this is not a separable differential equation. So the next step is to find out whether it's linear. And the first order derivative goes to the power of 1. And also the zeroth order derivative goes to the power of 1. And both of the coefficients are a function of x. And the right-hand side is constant, which we can think of it as a function of x too. So this is the first order linear differential equation. And we should write it in the standard form by dividing it by the leading coefficient. So this is p of x and this is f of x. So we need to find the integrating factor. Now that we have the integrating factor, we can find the solution to the given differential equation. And we know that the integral of 1 over cosine squared of x is equal to tan x plus the constant of integration. So now from here, we can find y of x, which we can write it as tan x divided by sine of x plus c divided by sine of x. And we know that tan of x divided by sine of x is equal to cosine of x. And this is the explicit solution to the given differential equation.